Hello, this is Mrs. Poland for Lesson 8.04, the chi-square test of independence. The chi-square test for independence occurs when investigating the relationship of two or more categories. So you're looking at more than one category and only one population. That's a key difference from the chi-square test of independence that looked at only one categorical variable and multiple independent populations. The procedure that we use for the chi-square test of homogeneity is the same procedure we will be using for the chi-square test of independence. However, the hypotheses and conclusions are going to be different between the two procedures. So, what are ways that we can write the chi-square test, the hypotheses for the chi-square test of independence? One way is in the null to say that there's no association between the categorical variables. The alternative is that there is an association. Another way the hypotheses could be written for chi-square test of independence is that the two categories are independent within the one population, and the alternative is that they're not independent. So let's go to an example. Below are 3,164 randomly sampled records from the 685,000 stops made by New York City police as part of this stop and frisk policy in 2011. Is there convincing evidence of an association between the race of a suspect and a level of force? So we see a two-way table, which is an indication of some sort of chi-square test. How do you know it's not chi-square test of homogeneity? Well, we only have one sample, not separate independent samples from each of the populations. That's the key difference. So therefore, the race of the suspect is treated not as a population, but rather as a category. And so they're comparing the category of race of suspect to the second category of the level of force. So here is how I would state the hypotheses for this chi-square test of independence. There's no association between race and level of force. There is an association between race and level of force. So you should put the video on hold and write that down. So there are three conditions. The first condition is random sample as stated. Notice we only have one random sample as opposed to yesterday's lesson with the chi-square test of homogeneity where we had separate independent random samples. Condition 2. It is reasonable to assume that there are more than 31,640 New York City records of stops in 2011. So what I did is I looked at the sample size and just multiplied it by 10, and certainly that makes sense since there were over 685,000 records. The third condition is all expected counts are greater than or equal to 5. See table below, and you actually have to verify it. So in order to verify, you need to have the row totals and column totals because we're going to need the following formula. So the following formula to get the expected counts is you need to multiply the row total by the column total and you're going to divide that by the grand total. So I want you to put the video on hold and I want you to list out all the total row totals, column totals, and grand total. So I have the column totals and row totals, and I'm going to just, actually, that's not correct. This should be 308. And the grand total is 3,164. That's better. Check to make sure that the columns are correct. And now let's go ahead and get the expected count for black with no force. So in order to do that, again, the formula that we're going to be using is row total times column total divided by grand total. So for this category, let me just switch colors. You want no forced use as the row, so the 2484. For the column, we need black, so 1743. And we're going to divide it by the grand total of 3,164. So let's go into our calculator and let's start a new document. You really should start a new document, especially for the chi-squared, so you don't run into calculator issues. So control division, parentheses. Again, that would be the 2484 times the 1743 divided by the 3,164 and control enter. So that would be approximately 1368. And you would have to do that for each one of these cells. So you would have a total of 9 cells. But there is another way. You do need to know how to do this by hand because there are multiple choice questions on this. But let me show you some shortcuts that we can use in the calculator. So we go into the calculator, and what you're going to do is go into the first row, the row 789, and to the left of the book key is a symbol key, and you want to hit, it looks like a matrix. And in this case, it's set properly. This is based on the data. So we had 3 rows, 3 columns. So this is not from the expected counts, but the original data that we're going to enter. And you create a matrix. Sometimes the number of rows and columns are different. So now we're going to enter the data. I made a mistake. So notice I entered all the data, and we're going to actually store that observed data into a variable. So if you go to the row above 789 in your calculator, you'll have a blue key control, and above the variable key is stored. So control store, and I normally use O for observed and hit enter. Okay, you're now going to perform the test. To perform the test, what you're going to do is you're going to do menu, statistics, stat test, and you want to do chi-squared two-way table. It's the same one you used for the test of homogeneity. So we're going to store that for O. Okay. And now you have your results. So we know that the chi-squared statistic is 10.1743, and the p-value is 0.0375. But we actually need to fill in the expected matrix. So how do you do that? If you go to the column where it's 963, above the 9, the variable key, if you hit the variable key, once you perform the test, you get all these variables. And we want the expected matrix, so you would click that and hit enter, and it gives the expected value of all. So put the video on hold, and I want you to fill in the expected. So here we have the expected values that I pulled straight from that variable. Again, you have to make sure to always start a new document with a chi-square test, because you will end up with problems if you do another problem. Okay, so now we have to name our test. So since conditions have been met, we perform and you have to state the specific chi-square test we're using. We're using a chi-square test of independence with blank degrees of freedom. So how do we calculate the degrees of freedom for the chi-square test of homogeneity and independence? You use the formula, which you have to memorize, row minus 1 times column minus 1. So we have 3 rows, so that's 3 minus 1 times 3 columns, 3 minus 1, so that's 2 times 2, or 4. So this is 4 degrees of freedom. We're now going to do our calculations. So the formula for the chi-squared statistic is the summation of the observed minus the expected squared over the expected. And you should show at the first and last. So I'm going to start with black and none. So the chi-squared statistic, they were 1371 black with no force minus the expected value, square divided by the expected value, plus, and you would have to do that for each one if you did it by hand, but now we're going to do white and higher. So that would be 19 minus 18 squared over 18. Okay, but we already performed the test to get the expected value, so we can actually just pull that directly from the calculator now, and we have 10.174. You really should do 3 or more. Okay, and so that's our chi-squared statistic. So now let's calculate the p-value. So the probability we get a chi-squared statistic greater than 10.174 is equal to chi-squared CDF, 10.174, 9E, 999, and 4 degrees of freedom. So we go into the calculator and we do menu, statistics, distributions, chi-squared CDF, and 10.174, 9E999, 4 degrees of freedom, and we hit OK. And we notice the 0.0376. Okay. Okay, let's make that look neater. So if I compare the 0.0376, that's my p-value, to 0.05, my alpha, it's less than that, so we know we're going to reject HO. So let's look at our conclusion. Since the p-value is less than 0.05, we reject HO. There's convincing evidence that there is an association between race of suspect and level of force. If you wanted to figure out which cell, you saw the discrepancy, you could actually go into the calculator and hit var and see each component. So where were the big differences? Hit enter. Well, so where were the big differences? We see the last row, last column. So position 1, 3, first row, third column. Position second row, second row, second column, and second row, third column. So those are the major discrepancies. And so if we look back at our actual data, okay, we see there was less than expected with Caucasians, and then you can see that there's more than expected with Hispanic, and less than expected with used. Okay, hopefully you found this interesting, and I will see you tomorrow.